All right. So I'm going to totally make these numbers up. Okay? Totally making them up. I don't know how it'll work out, but let's have some fun with it. All right. So I do not know why my is not working. Great. Now I have to edit this thing. Okay. The mass of the metal, I will say, is 50.000 grams. The mass of the water, of course, is Y 150.0. I didn't measure the mass of the water. What did I do? I measured the volume of the water. But because density is 1 gram per 1 milliliter, then the volume is the grams. The temperature of the boiling water is the initial temperature of the water in the calorimeter is the highest temperature the water in the calorimeter attained. And I'd like for you to get 2 trials, but I'm not sure that we'll get there. All right, so how do we find the temperature change for the metal? Look at the data that I gave you. What is it? Raise your hand. Yes. Good. It says it right there. What is the final temperature and what's the initial temperature? Is your of water. I asked you for the metal. All right, keep in mind, there's no way to determine the temperature of the metal with that thermoprobe. No way, because we're blind. So what do we use in order to tell us what's going on with the metal? The water. So the final temperature is the temperature of the water once the metal has warmed it up. When the temperature stops moving, we assume, according to the law of the second law of thermodynamics, we assume that the temperature of the metal and the water are the same. So we actually measured the temperature of the water here, and we're assuming that that is also the metal's temperature. Once again, to find the initial temperature, there's no way we can know. Okay, so once again, we are using water in order to tell us what that initial temperature is. So it has been sitting in boiling water for 10 minutes. So we assume that the temperature of the water is the same as the temperature of the metal. So what is the temperature of the water? Okay, that is the temperature of the water after. That's your mass of the water. Yes. Okay. So I don't want to use any names. You with the face over there. What is the difference there? You over there who was helping me, do you understand now? Okay. Yeah. It's clearer now, right? You, who I called on, what is it? Very good. You kept that negative. It needs to be negative. Very good. This is not the way I taught it to you, but we're just doing it piece by piece. What is the temperature change for the water? You. What do you want to do first, final or initial? Okay, what is the final temperature? Very nice. And what is the initial temperature? Okay, that is the water whose job was to heat the metal. Remember, common mistake. There are two waters here. Water number one's job is just to get you an initial temperature for the metal, just to boil. That's it. That's the only job it'll play here. It needs to give you the initial temperature of the metal. It needs to heat up the metal. The water that we are really concerned about is the water in the calorimeter. What is the initial temperature of the water in the calorimeter? That is the temperature after the metal was added. That is the final temperature. So what is the initial temperature? Let's look up here again. What is the initial temperature of the water? Tucker, give me a difference. All right. Believe it or not, we just overcame the most difficult part of this. Trying to figure out what all the temperatures are. And I'm so glad that you guys made these mistakes because they are the most common mistakes that people make. And I'm glad it's going to show up on this video so that when people are doing this at home, they won't make this mistake. All right? So this is the temperature of the water when it was boiling. This is the temperature of the water after the metal has been inserted in there and has warmed up. This is the temperature of the water before anything happened. And this, of course, is the temperature of the water with the metal. Are you beginning to understand what I mean by, the blind man's fingers? We basically have to measure the temperature of the water in order to tell us what's going on in the other part of the world. All right, so since what we need is specific heat of the metal, and we don't have all the pieces of information, then we need to find how much energy the metal absorbed. Remember, we will have mass, we will have change in temperature. This is what we need to know. We can't have two unknowns. So how do we find Q? By finding the Q of the water. U, mass of water? Change in temperature of water? Specific heat of water? Should be on the back of your periodic tables. 4.18 is good enough. All right. Seabass, calculate. Yes? Yes? 6,270 ... And since it's joules, you need to have a positive or negative. Therefore, Jogel, if you know that the energy that the water absorbed is a positive 6,270 joules, how much energy did the metal give off? Awesome. Now, can we use everything else to figure out the specific heat? Yes. Negative 62.7. Mass, I don't know. I don't remember. I made it up. 50.000. Change in temperature. It's all for it. Hopefully, it'll be a decimal. If not, then these numbers I made up were bad numbers. Who's got it? Anybody? Go, you. How about 1.87? Oh, man. Yeah, that's not possible. So, those are really, really sucky results. What's the closest thing to this? Closest thing to 1.87? Aluminum. Okay, so aluminum, question mark, question mark, question mark. Percentage error, true. What is the truth? What is the truth? Minus observed, which is what I got, which is really, really bad. Divided by what? Who remembers? So this is absolute value of times. Oh, this is going to be brutal. Brutal. Anybody? 108. Oh, that hurts. Okay, so let's go through all our data and check for significant digits. 5, 4, 3, 3, 3. So our final answer needs to be in 3. 3. Okay, so we did it right.